Yeah. Very good evening to all of you. I welcome all the faculty members who have joined this AROHAN series 23. Today we have 4 lecture series from different research persons. So 2 are from in-house government engineering colleges, and 1 is from BMS IT, and another is from industry. So on behalf of all the participants, I welcome today's first speaker, Dr. P.B. Nanamurthy, the Associate Professor of Civil Engineering Department, Government Engineering College, Ramnagar. And today we'll be delivering a talk on that is innovative infrastructure solutions, a collaborative approach to environmental sustainability in road design. Dr. Nanamurthy, on behalf of all the faculty members, I welcome you.
Thank you, sir.
Am I audible, Nanamurthy? Yeah, you can continue.
Sir, yes, sir. Sir, am I audible, sir?
Yeah, you're audible. You can start sharing your slide and you can start. Madhura madam will coordinate with you. Madhura madam?
Yes, sir.
Yeah, please. Yeah.
Thank you, sir.
Continue.
Yeah. Good evening, everyone. Am I audible?
Yeah,
Yes,
you're
sir. Audible, sir.
Continue. Please continue.
Thank you.
If anything is there to share, you can share it.
Sir, is my presentation visible?
Yes, sir.
Yeah. Thank you, madam. Good evening, everyone. At the outset, I would like to thank our Principal Secretary, sir, Commissioner, madam, and Director, sir, and organizer of this lecture series, AROHAN lecture series, Professor Basuraju, sir, for creating this platform and providing me this opportunity to share my experience with the various stakeholders of the team. Yeah, the title I have selected for today's presentation is Innovative Infrastructure Solutions, a Collaborative Approach to Environmental Sustainability in Road Design. So, since I am from civil engineering, specialized in highway engineering or highway technology, I have chosen this topic. Though this topic appears to be very technical, I am not going deep into the technical aspects of this project or this presentation. Instead, my intent is to inspire or motivate student community and upcoming researchers to take up collaborative projects or interdisciplinary projects of this kind to address present societal issues or needs. So in this regard, for next 30 minutes or so, I'm going to take you all through a successful story of our own Government Engineering College. In fact, a journey which led to the development of sustainable road design methodology, which was possible in collaboration with the industry, academia, and government. So I have formulated my presentation with this following contents. That is, first I will be introducing you to the problem statement or background of the problem which we have selected, and followed by our scientific approach to the above problem and key outcomes or benefits of our study or our research work. Then a case study to showcase the process since the inception to the end that was involved in development of this sustainable project. and finally the conclusion or call for action and acknowledgement. So to begin with, the main objective of our project was to develop a environmental friendly, economical, effective or efficient road design methodology for initially our scope was to rural roads or low volume roads we say. Right? So that means main aim was to design a sustainable road design methodology. So sustainability means, what do we understand by sustainability? So which is we are sustainable in the sense which is very effective, efficient, which minimizes the waste or energy consumption using locally available material or marginal material. That means overall which contributes to the or which reduces the environmental impact of road construction. So in this direction, when we decided to design a sustainable road design, the challenges or problems that were there was, first thing was challenges in the conventional road construction. Right? So in road construction, if we take the material that we use for road construction, the major material that comprises of our road structure is road aggregates. That is stones in common language we call it as, right? So this road aggregates, this is obtained from the quarry. This is obtained by mining the granite quarry or stone quarry. Right? So if we go on mining this stone quarry for the construction of roads, because our India is the second largest road network in the world after US. So we have 66 lakh kilometer length of roads comprising of all categories, starting from expressway, national highway till village roads, right? So if we go on mining this stone aggregates for the construction of roads, there will be a day when we will not be having any stone, any natural resource of stone for the road construction, right? So that led to think of alternative materials or locally available materials or marginal materials. So that was first thing. Next, then the mining. We know that this mining of this road aggregates or anything for that matter will cause us problems like erosion, sinkholes. That means loss of biodiversity. That means ecological imbalance and contamination of soil, groundwater, and surface water. So all these problems are associated with this. So this was the first problem. Next, in addition to this, the issue or the crisis that was with the plastic waste, this was also growing. Every day it is growing, right? So if you take globally, we are producing, as per the 2023 statistics, we are producing 400 million tons of plastic every year. So the major 5 countries for this contribution are United States, India, China, Brazil, and Indonesia. So you can imagine if we produce this much of plastic waste and if we don't have proper disposing technology or reusing technology or recycling technology, so then this will be a menace, right? So out of this 400 tons, only we are using 9% for recycling, 9% for recycling. So this plastic waste, this is causing problems such as the incineration of this plastic waste. It is releasing toxic gases, and that means the rest, whatever I am talking about, the 9%, it is going for recycling. So rest, it is ending up in reaching oceans or water bodies and landfills, and for incineration, that means burning, right? So that burning, it releases toxic gases landfills, it makes that land or soil that will not be used for anything. Then it is also causing damage to the marine bodies. So all these problems are associated with this plastic waste. So first thing is the challenges or problem with the conventional approach in the road construction. Then this plastic waste. So we thought of coming up with a sustainable solution or a solid solution to address these issues in the road construction. So this increasing plastic waste crisis, along with the directional road construction, it calls for a sustainable alternatives, right? So for this, we have developed our own approach to address this problem. So what makes our project or what makes our approach unique or different? So we are making use of recycled aggregates and waste plastic for the road construction, thereby conserving the natural resources and also giving solution to the waste management, right? So with this intent, our main aim was to develop a sustainable road design technology, and we are not stopping at this stage. That means we are just not providing the design. So we are also testing our design with validation. That means with valid performance analysis, because nowadays any individual personnel or any authorities, implementing authorities or policy making authorities, they need proof for everything. That means if you are coming up with new technology, they need proof for its survival, isn't it? So for that, we have also validated our design with field and laboratory performance analysis. So when we started this project, we had challenges like any other new projects. So technical challenge was that availability and quality of recycled materials, because we are making use of recycled materials in the construction. So the quality also matters. We cannot use whatever the material that we get from the debris or whatever the material that we get from the landfills. So that quality also matters, because it has to fulfill certain qualities which it has to be used in the road construction. Secondly, lack of standard design codes or specification or methodology, in other words, we can say. So that was the technical challenge for us. Then public awareness, lack of public awareness. See, when we try to introduce anything new, definitely there will be a resistance from the stakeholders, isn't it? So limited awareness of this technology or the construction methodology. So that was also a challenge for us. Then construction and implementation challenges, because since we were using plastic waste and recycled aggregates and all. So for using plastic waste, at which stage we have to use that plastic waste? So that was also a challenge. Then that means skilled labors are a proper design methodology for the contractors or for the labors. So that was also a challenge during implementation. So in order to overcome all these things, that is technical, this awareness with the individuals, and construction and implementation challenges, we took help of our collaborative partners, that is academia, industry, and government. So we took help of industry to procure the suitable material for the construction, and also to assist with financially for the implementation of this project. And we took help of government to come up with the policy support or for application of this design or technology in the real world. And academia, that means us. So that means since we had that idea or technical expertise with us, so with the help of industry and government, we could able to come up with the sustainable or environmental friendly or eco-friendly, economical and sustainable design for the road construction. So major key outcomes of our project was, since we were making use of recycled material, so the recycled aggregates especially, and plastic waste. So firstly, we could able to come up with the novel pavement design technology, and secondly, so environmental and economic benefits, such as our design was eco-friendly because we were reusing the used material, and we were also using the waste plastic, which is a waste, and we could able to provide innovative solution for waste management, and this led to reduction of plastic waste, reduction in plastic waste, and this our approach led to a dependency on the virgin material. That means conservation of natural resources. Then we were also contributing to the circular economy, that is reuse and recycle. Then we also done a cost analysis, which that means which proved us, or which given us a better results. That means our approach was economical when comparatively economical with the conventional method. And this was also creating employment, because that means we need people for recycling the materials. We need people for segregation or processing the material plastic waste, and we need people for construction. So thereby it is giving contributing for creation of employment and skill development. Not only that, this approach, or our design approach, it also led to some innovations. So one of the innovation or invention I can say is, so we because as the saying goes, necessity is the mother of invention. We invented this instrument for the processing of the recycled aggregate, which we used in our road construction. So because we cannot use the recycled material as it is available in the landfills, so it needs to be processed. So this was our invention as a result of our project. And also, in addition to this, for performance analysis, that means to validate our result, so we also invented this instrument. So this equipment, this was designed by our project head, Professor Kiran Kumar Bevi sir. So under his guideship, or under his leadership, we could able to come up with this instrument, so which used to ascertain, or which used to assess the performance of the pavement in the laboratory. And this instrument, this was developed to establish very strong correlation between field and the laboratory results. So this was the outcome of our research project. So that means if we have innovative ideas, so with the proper collaborative partners, we can come up with, or we can contribute to the societal problems, and also we can come up with the great innovation and invention. That was our idea. So in order to support my earlier statement, I would like you all to take through my case study, in which you will come to know the process that was involved since inception to the end. So this was the steps or methodology that we were followed in our research project. That means first stage would be design of that road. Then second stage, in order to validate that design, construction of a test track at the field. And that performance analysis or performance evaluation of that test track, both in the laboratory as well as field. Okay. So this stages will validate our design. So since our objective was to formulate the sustainable construction methodology, initially our aim was, or our scope was limited to rural road. So, but when we got this the test track construction, or when we visited the test track construction site, so there we come to know that, so that road, so we initially designed for low volume roads. Low volume roads means they are the roads in which generally the traffic would be per day, the traffic would be 250 to 300 vehicles. So whereas when we visited that site, so the traffic was varying from medium to high. That means it was more than 400 vehicles per day, 400 to 600 vehicles per day. So we did some minor changes in our design, and we could able to construct that test track successfully with the help of our collaborative partners, that is government and the industry. So the material that we used for the construction of test track, that is virgin material. That means we used a formula of having virgin material in 20% and recycled material 80%, 80 plus 20. So with that formula, we designed, we come up with the design, and we implemented, or we applied that design in the test track construction. So recycled aggregates. So these are the samples of recycled aggregates. So this on the left hand side, this was obtained from the recycled material from the SH82 site, and this was the milled material. So milled recycled material that is processed and used in our test track construction. So waste plastic that we used in our construction in the form of shredded plastic. See, this was also a challenge. That means we get different this waste plastic in different forms. We cannot use all the forms which are collected. So this also needs to be segregated, and this also needs to be brought to certain shape. So we used shredded plastic for our design, or for our road construction, test track construction. So with the help of Messrs. KK Waste Plastic Management Private Limited, Bangalore, so they supplied this waste material. They collected, segregated and processed, and they supplied this waste material. And as per the standards, 8% of this shredded plastic was used with the bitumen. So test track location. So this test track location was given by K-Ship, which is subsidiary of PWD department. So they were running a World Bank project under which they wanted to build a eco-friendly technology, or they wanted to implement a eco-friendly technology. So when we approached K-Ship, so they agreed, and they sanctioned this construction of test track using waste plastic and recycled aggregates at some site. So the site that was allotted to us was located on a major district road near Hoskote. So the problem with this site was, so this major district road was giving connectivity to two major roads. One is state highway on the left hand side, and the other one is national highway on the right hand side. So people who used to connect with this national highway from state highway, they need to go around for about 8 to 10 kilometers without this major district road. So what people were using, so since to avoid this hardship, so they were making use of this major district road itself. So that is why, though it is a major district road, a low category road, So the traffic was almost medium to high or heavy because of this complexities. That means it is giving connectivity to two major roads. That is State Highway number 82, which was giving connectivity to Chintamani town from Bangalore. And the other one is National Highway 75, which is connecting Kolar city from Bangalore. Okay, so because of that, we were experiencing more traffic. So this is the close-up view of our site. So here we got 500-meter stretch for test track construction from chainage or kilometer 14,500 to kilometer 15. So on this, with the help of our industry partner, we could able to construct the test track for a length of 500 meters using our sustainable design, that is making use of recycled aggregate and waste plastic. So recycled aggregate we used up to 80%, and virgin aggregate we used up to 20%, and waste plastic 8% of the weight of the bitumen. Yeah, so this was our key points. So this was the photograph taken before construction of our test track, which was that means in very damaged condition. So after construction of overlay with the help of waste plastic and the recycled aggregates, this is the finished road surface. Okay, so this surface, it was serving its purpose for longer duration, so that we validated through field studies. Okay. So we carried out this field studies. We say performance evaluation of this road in 2 cycles. One cycle before monsoon, that is pre-monsoon cycle, in the month of May 2015, and the second cycle in the month of November. Okay, so that is post-monsoon. So the test results. Sir,
I think you need to wind up in another 3-4 minutes.
Okay, sir. So then, so I will directly go to conclusion of my presentation.
You take another 5 minutes, no issue. You take 5 minutes.
Okay, sir. Okay, sir. So our design was economical too. For that, we did a cost analysis comparing with the conventional. We call it as control mix design and our design. So the cost per square meter was conventional was 75 rupees per square meter. So the design, our new design, our new technology was 46 rupees per square kilometer. So thereby a saving of 38.4%. So this savings of 38% was very considerable when we take up this project in a larger extent or larger scale. So this was we validated our design with laboratory performance analysis. So the equipment which we invented is for rutting analysis. Rutting is a distress, a permanent deformation which is caused due to the repetitive loading. So in order to assess that one, this instrument, our instrument, this correlates both field as well as, or it gives better correlation with the field and the laboratory results. Okay. So conclusions or major key takeaways from this presentation is, so we can conclude that from the test results or from the benefits what we have seen from the earlier slides, we can conclude that we can design, it is possible to design acceptable quality bituminous mix with high RAP content and plastic waste for low or medium traffic roads. And this type of projects or this type of approach, it encourages practicing engineers, researchers, and project implementation units, contractors for effective use of recycled materials to come up with the low cost and time tested designs. So we can say that, finally, we can say that innovation and collaboration, it will lead to sustainable future. So students or researchers, they can think of coming up with this kind of projects. That means interdisciplinary or collaborative project, which will address the societal issues. Okay. So this was the talk of the town during 2019. So in which our Kempegowda International Airport made use this plastic waste in their road construction, internal road construction. And our one of the collaborators, that is KK Plastic Waste Management, they were the supplier of this plastic waste for the construction. Okay. So with this, I would like to acknowledge the support extended by the various collaborative partners, that is from government, KSHIP, for giving permission to construct the test track and awarding this performance evaluation project, and industry, Messrs. KK Waste Plastic Management Private Limited, for supplying recycled materials, waste plastic, and helping us in construction of the test track, and Messrs. Infra Innovate Marketing Solutions, New Delhi, for funding development of that equipment, and our research team from the academia, our research team under the leadership of Professor B.B. Kiran Kumar sir and Professor Manjunath sir, Dr. Praveen Kumar sir from GSK State Bangalore, for their technical support, and assistant from our MTech Highway Technology students who helped in carrying out the performance evaluation test both in field and laboratory. Okay. So with this, I would like to conclude my presentation saying that collaborative approaches will lead to the sustainable solutions for the societal problems.
Okay, thank you very much, Ganamurthy.
Thank you, sir. Thank you, sir. Thank you, sir.
Informative talk on. I think you have a lot of hands-on experience, so you'll be able to explain better. Hope all the participants might have benefited from this talk. And any questions from audience? If you have any questions, you can ask. Okay, Ganamurthy, I think there are no questions for you. Thank you very much for making your time and delivering this talk. On behalf of all the officials of DTE, Commissioner and Secretary, thank you very much for your valuable time.
Thank you, sir. Thank you, sir.
Yeah. Next, we'll have the next speaker. She is Dr. Tejaswini RM, Associate Professor from Department of Civil Engineering, Government Engineering College, ASAN, and she'll be delivering the talk on soil structures interaction. Madam, are you there?
Yes, sir.
Yeah. Yeah. So over to you. Or if you have any slides prepared,
Nice.
you can share the slides.
Yes, sir. Yes. Thank you, sir, for giving me an opportunity. I would like to thank Principal Secretary, sir, Director, sir, Commissioner, ma'am, and our coordinator, Basuraju, sir, for giving me this opportunity.
It's not full screen, madam. You make it full screen.
Full screen, okay, sir. Okay, sir. So today I'm presenting.
Still, do one thing. You just stop sharing screen, go back and share the full screen and yeah. You share it with full screen. Full screen option will share, madam.
Third tab, madam, entire screen. Ma'am,
In this entire screen, I am getting only this one, ma'am, video chat. I am not able to get this full screen.
video chat. Third tab, entire screen. Then click on that entire screen. Then share, madam. Go to entire screen, third tab. Then click
Yes,
that
ma'am.
entire screen below.
Uh,
Then share.
Share, yeah.
Yes, ma'am.
Yeah, you open it.
Now go to
Yeah,
PPT.
you make it full screen. Yeah.
Yes, ma'am. Okay.
Continue, madam.
Okay. So today I'm presenting a topic on soil structure interaction. So the soil structure interaction needs to be considered in the study to ensure the structural safety and for human life. So the contents of the present study includes introduction, types of foundation, types of soil, shear wave velocity of soil, soil structure interaction, detrimental effects of soil structure interaction, numerical study, considering finite element method of analysis, and conclusions. Most of the buildings have been constructed for the occupational purpose across the world. So these buildings are constructed on various types of soil. Most of the buildings are also constructed to enhance the aesthetic view as well as daylight effect. In doing so, some of the buildings, in the analysis of the buildings, they will neglect the soil structure interaction, which plays a major role in the analysis and design. And also, due to the unavailability of plain land, most of the buildings are also constructed on the sloping ground. So in this sloping ground, some of the buildings will be rested on the hard rock and some of the buildings will be rested on the soft soil. In recent past, many Can you able to hear sir?
Yeah. There was a break. No, it's okay. You continue, madam.
In recent past, many of these buildings have been damaged or suffered majorly due to landslides, inertia loads, kinematic action of soil, and due to earthquake across the world. The structural response of these buildings needs to be considered considering soil structure interaction. The soil structure interaction is a phenomenon where the structure behavior is not independent of the soil it's built on. The structure's motion and the soil's response are interdependent. The response of the soil affects the motion of the structure, and similarly, the structure's motion influences the soil's response. The structural response to an earthquake is highly dependent on the interactions between three linked systems, namely the structure, usually called as superstructure, the foundation, usually called as substructure, and the underlying soil. The substructure is a structure which is built above the soil, and the superstructure is a structural element which is built or embedded in the soil. So different types of structures will be there, namely low-rise buildings, medium-rise buildings, and high-rise buildings. Depending upon this type of buildings, the foundations are classified. So they are broadly classified into two types, namely shallow foundations and deep foundations. Isolated footing, combined footing, strap footing, grillage footing, and mat footing falls in the shallow foundations, and pile foundation falls in the case of deep foundation. Usually for medium-rise buildings and low-rise buildings, we will provide shallow foundation. And for high-rise buildings, we will go for pile foundation. Also, types of foundation depends upon the type of soil where it is placed. Now coming to the shallow foundation, it is classified into this type, that is isolated footing. Isolated footing is a rectangular footing or a square footing. They are constructed to support a single column. And a combined footing comes in place when columns are closely spaced and the footings are overlapping. In that condition, we may provide combined footing. The strap footing is a foundation that connects multiple footings with a concrete beam. It's used to distribute the weight of the building across the larger area of the soil. A grillage foundation is a shallow foundation that uses grid-like framework of beams. That is, sometimes we will use steel sections as it is shown in the below. It carries the heavy loads from the structure over the large area, particularly on the soils, with low bearing capacity. Mat foundation or raft foundation cover the entire area of the building, supporting heavy loads from the columns and walls. This type of foundation is chosen to prevent differential settlement, which usually occurs in the buildings which has higher areas. Pile foundation falls in the category of deep foundation. Again, there are different types of pile foundation depending upon the load carried by the column. If a column carries less load, in that case we may provide single pile. And if the load increases, then we may increase the piles depending upon the load, that is 2 pile foundation, 3 pile foundation, so on. While designing that, we will provide a pile cap which holds all the piles together. So again, type of foundation depends on different types of soils also. Like as it depended on types of structure, the types of soils also plays a very important role in considering the type of foundation. There are 5 different types of soils, namely sandy soil, clay soil, loam soil, peat soil, and rock soil. In sandy soil, it contains large particles. It does not retain water, offers quick drainage. Usually, this type of soil is helpful because it effectively prevents waterlogging and structural damage due to moisture. And clay soil contains tiny particles, has a tendency to expand and contract. Due to this expansion and contraction cycle, it has become a challenge to design a foundation. Before designing a foundation, we need to properly plan. And loam soil is a balanced mix of sand, silt, and clay. It is a stable type of soil, and it is a perfect balance and it provides a perfect thing for the providing a foundation. Peat soil, again, it retains larger amount of water and it has high risk of damage, and it should be treated before providing a foundation over it. And lastly, it is a rock soil. It contains very good bearing capacity. It contains very good bearing capacity. and the foundations provided over a rock soil it will give a stable strength and gives the longevity for the foundation. Again, foundations used depending upon the type of soil. For rocky soils, rocks such as limestone, granite, sandstone, and hard solid chalk have a high bearing capacity. When the soil is rocky with high bearing capacity, then isolated footing, combined footing, and a strap footing will work well. The preferred depth of the foundation is less than 0.7 meter. This type isolated footing and combined footings are sufficient in case of rocky soil. If we come to sand soil, if the bearing capacity is high, then the isolated footing and combined footing work well. If the soil is dense and has a high bearing capacity, if the soil is loose, in order to avoid settlements, we need to go for deep foundations. If we come for hard clay, again clay soil is classified into two types, hard clay and soft clay. When we come to hard clay, if the moisture content, when the moisture content becomes stable up to certain depth, it becomes suitable for the substructure. In that case, raft foundation is preferred. When the clay soil is compact and hard, sometimes we may provide strap foundations also. In case of soft soil, the soil itself will be very soft and it contains very low bearing capacity, and it is unsuitable for shallow foundation. In that condition, we should go for pile foundation. Peat soil. Peat is one of the poor subsoil for foundation. If the layer of the peat is excavated, that is removed from the ground till a stable soil is found, then strap foundation may work. If in case no stable soil is found, then we need to go for raft foundation or mat foundation. In case of loamy soil, shallow foundations and deep foundations both are suitable. For single-story buildings, stick footing, combined footings may work well. For high-rise buildings or multi-story buildings, we may consider pile foundations. Again, the soil types varies depending upon the shear wave velocity. This we will call it as stiffness of the soil, whether the soil is stiff, hard, or soft. This also plays an important role in the foundation, considering foundations. The main characteristics of the soil stiffness, we will consider it as a shear wave velocity. If shear wave velocity is less than 300 meter per second, then the soil is considered to be soft. If shear wave velocity ranges from 300 meter per second to 800 meter per second, then the soil is considered to be stiff. If the shear wave velocity is above 800 meter per second, then the soil is considered to be hard. Similarly, if it is over 1100 meter per second, then the soil is considered to be rigid. Why we are considering this shear wave velocity? Because during earthquake, this bedrock as well as hard rock soils doesn't amplify the shear waves. As you can see in the figure, shear waves have not been amplified in the bedrock condition. But when these shear waves come in contact with the loose soil or soft soil or medium stiff soil, the amplification of the amplitude increases. As we can see in the figure, the left side, the amplification of the seismic waves are comparatively less when compared to the middle part, where the amplification of the shear waves are increased considerably. So when this resonance of these waves matches with the resonant frequency of the buildings, that buildings will be vibrating, as you can see in the figure. In the coming from left, the tall story structure is getting vibrated. with the frequency, matching frequency with the waves. And the second one, low-rise buildings catch the resonant frequency with the seismic waves. The amplitude of the structural response is affected by the additional energy dissipation introduced into the system through radiation damping and material damping in the soil. Soft soil sediments can be significantly elongate the period of seismic waves. The increase in the natural period of the structure may lead to the resonance with long period ground motion. Permanent deformation of failure of soil may further aggravate the seismic response of the structure. As we can see in the figure, when the waves gets amplified, the time taken for the waves to travel from here to here will be more, as well as the amplification also will be high. Therefore, the the time period of the structures will be increased. In that condition, the structure will fail, as well as in this course, due to the increase in the amplification, soil also gets damaged, resulting in the failure of the structure. Therefore, soil's interaction with the structures needs to be a part of seismic design, as these influences can change the dynamic features of the system significantly. Influence of underlying soil on the seismic response of the structure can be neglected when light structures founded on stiff ground, and consequently the structures can be analyzed considering fixed based conditions. If we are considering lightweight structures constructed on very stiff soil, in that condition we don't need to consider soil structure interaction. That is, if this type of structures are there and if they are constructed on the hard rock, then we need not consider any soil structure interaction. We can analyze the structure considering only structure founded on hard rock or a fixed based condition. Only we need to consider soil structure interaction when the soil is weak and the structure is heavy. Soil structure interaction analysis is used to evaluate the effects of seismic ground motion on a structure, ensuring it is designed to withstand earthquakes without compromising safety. Soil structure interaction phenomenon can be simulated in engineering practice, and specific recommendations for modeling seismic soil structure interaction effects on building structures are provided. So we need to consider this soil structure interaction if the buildings are considered on the soils. Also, when the buildings are constructed in the same height buildings, if they are constructed in the rock and if they are constructed in the soft soil, we should treat them as differently. So in this study, we have considered 5-story RC buildings to observe the behavior with and without effect of the subsoil condition. For this, we have considered a special moment resisting frame located in seismic zone 5, having an importance factor 1, and type of the soil we have considered as rock. That is, this is a condition for fixed base condition. And for structural elements such as slab thickness, we have considered it as 150 mm, beam dimension as 300 mm by 400 mm, column dimensions as 250 mm by 600 mm. And when we consider soil structure interaction, for this we have considered very soft soil, because very soft soil only will create more amplification of the seismic waves and cause the damage for the structures and human lives. So for the soil, the properties of very soft soil are Young's modulus as 25 MPa, Poisson's ratio is 0.4, density of soil is 1470 kg per meter cube, and shear wave velocity is 200 meter per second. Since we have considered soft soil, pile foundation has to be designed. The designed parameters of the pile foundations are shown in this table. Pile size is of 0.7 meter by 0.7 meter. Pile length is 9 meter. Pile spacing is 3 times the pile size, and pile cap size is 1.4 meter by 3.5 meter by 0.7 meter. So this is the fixed base model and the flexible base model. Both the superstructures are same, but the foundation for the first condition we have considered fixed base, and for the second condition we have considered the flexible base. So when considering the soil, we need to see that the width of the building, the width of the soil which we are considering, it should be 5 times the width of the building. For example, if I am considering 12 meter as the width of the building, then the width of the soil I need to be considered as 5 times the width of the building. That is 12 5 is 16 meters. So all the this is the soil structure interaction model. This is 60 meter by 60 meter, and this green color, as whatever you are seeing, is the fixed ends. At the 60 meter end, we are fixing the boundary with the fixed conditions. Near the foundations, we are just providing the pile cap and piles. We are not fixing any conditions. But in fixed base conditions, below the columns, we are providing the fixity conditions. So this is the soil structure interaction model, which contains the both piles and pile cap. The pink color which connects the two green piles is called as a pile cap. This pile and pile cap are designed for the single column, as you can see in the figure. So for this both fixed base condition and for soil structure interaction condition, an earthquake motion is provided. For this, I have considered El Centro north-south earthquake, which has given as an input motion in the finite element analysis. Further, the results such as frequency, damping, and story displacements are observed. If we give the input for the building, for the fixed base building, the building starts resonating, and this is the first mode of resonation, as you can see in this video. Entirely from the ground is fixed here, but from story 1 to story 5 is vibrating. When we come to the soil structure interaction model, here is also we are given the El Centro motion, but here the building is also vibrating in the first mode, but here the foundation is also vibrating because we have considered soil in this condition. So as you can see in this longitudinal section, the soil foundation is embedded in the soil, and the entire building is moving to and fro. This is considering the displacement of the soil also. So the frequency and time, comparing the frequency and time period of both the buildings, the frequency of the fixed base building is 1.36 Hertz and flexible base building is 1.05 Hertz, and time period is 0.74 for fixed base condition and 0.955 for flexible based condition. That is, if the wave reaches 1.36 Hertz in fixed base condition, then only this building gets resonate. But the flexible base building or soil structure interaction building gets resonate with lesser Hertz only. So comparing the displacements of the building, the fixed base buildings are varying from 18.67 mm to 79.76 mm from story 1 to 5. Now comparing this build displacement with the flexible condition, in flexible condition, the displacement is 111.63 mm to 233.48 mm, almost 5 times greater than the fixed base condition. As we can, if we see the plot, the flexible base building has much more displacement compared to fixed story building. So in this type of conditions, if we neglect the soil structure interaction, there will be chances of more displacement and damage for the structures. Now coming to the damping of the structure, damping of the fixed base model is just 4.36%, and the damping of the soil structure model is 8.8, approximately double the damping of the structure. Now coming to the conclusions, the resonant frequencies of building resting on flexible base have decreased considerably in comparison with the building with rigid base, indicating the effect of subsoil on the seismic response of the building. From experimental study, it is observed that damping of the building resting on flexible base is more in comparison with the rigid base structure. By considering the effect of soil structure interaction, it is observed that story displacement of the buildings are increased considerably than that of the buildings analyzed without considering soil structure interaction effect. That means if the building is a tall story structure and if it is rested on soft soil or medium stiff soil, then we need to consider soil structure interaction. If the same building is constructed on the hard rock or stiff soil, then we can ignore the soil structure interaction. These are my references. Thank you for providing an opportunity.
Okay, thank you very much. Any questions? Any question from audience? Okay, I think there are no questions, madam. So thank you very much for your talk.
Thank you, sir.
Time. And we have next speaker from outside. Deepak, have you joined?
So I'm here, sir. I'm here. Can you see me?
Great. Yeah.
Yes, sir. Yes.
Just a minute. Yeah, today we have a distinguished speaker from BMS Institute of Technology from Computer Science Department, and he will be delivering talk on. One second, just. Yeah, he'll be delivering talk on knowledge-driven artificial intelligence (AI) in quantitative decision making. Today we have Gerard Deepak, Associate Professor from Computer Science and Engineering Department of BMS Institute of Technology and Management, Bangalore. So it's my great pleasure in introducing him briefly. Dr. Deepak holds a PhD in Semantic Artificial Intelligence from National Institute of Technology, Tiruchirappalli, and he holds Masters in Engineering degree in Computer Science and Engineering from UC Bangalore, and Bachelor's of Technology in Information Technology from Anna University, Chennai. And he is a university level first rank holder for his Masters. And he has received Outstanding Researcher Award from National Institute of Technology, Tiruchirappalli, thrice, successfully for the academic year 2020, 2021, and 2022. Dr. Deepak has featured in the World Cup World's Top 2% Global Scientists by Stanford University, USA, for the year 2022, 2023, and 2024. So currently he is an associate professor at BMS Institute of Technology and Management, Bangalore. And he has been a part of prestigious institutes like many colleges of technology, Bangalore, Christ University, and even he has got industry experience such as Cognizant, Usable Bytes, and Space Age Technologies. Previously, he was with cumulative experience of 10 years, and he has published about 175 research papers in peer-reviewed Scopus industry conferences and journals, and he has received Best Paper Award 12 times in several international conferences and in India as well as in abroad. To this date, he has 1,900 plus citations with an H index of 25. So, remarkable achievement at this age.
So
And
thank
he has, yeah, his areas of interest include semantic web, explainable AI, semantic artificial intelligence, information retrieval, ambient intelligence in human-centered computing. Deepak, it was great to read your profile.
So thank you so much. You should not have read so much. You
Yeah,
know.
no,
Thank
it's my pleasure in reading your profile. It's actually having
Thank
a
you.
great weightage.
So,
And having,
eminent professors like you and Professor Venugopal Kher only motivated me to build my, profile. Thank you for that.
thank you, Yasmin Guru. And having 1,900 plus citations at this age with the H index of 25 is not easy. So it's our honor to be on the board to share your knowledge with our staff members of government engineering colleges.
Yes.
So over to you, Deepak. Thank you.
So is my screen visible?
1 second. Yeah, it's visible. Yeah,
Yes.
it's visible.
So very good evening to my dear friends, faculty members of various government engineering colleges. I, Dr. Gerard Deepak, is presenting the topic titled Knowledge-Driven AI for Quantitative Decision Making. So first half of our talk, we will be talking about what knowledge modeling is, and second half is how can we make decisions using quantitative AI techniques. So let's understand two types of problems. Any problem today, any computing problem today, we have two types of problems. One is a closed domain problem. Other one is open domain problem. So closed domain problems, they require domain knowledge. Be it legal document retrieval problem, or be it medical knowledge representation, or medical document recommendation, or medical report summarization. So these are all closed domain problems, highly specific to one domain. So if it is medical report generation, then we can also call it as radiological report generation. Subdomain, it can be only for a spine pathology, or can be for a hepatobiliary pathology. Open domain problems are like the very regular problems, like the web search problems, web image retrieval, where we can use a search engine, or ChatGPT interface, and we could search anything from any domain, which has basically interdomain. The only difference is in closed domain problems, specialized and very minute and highly detailed information is required for retrieval, whereas in open domain, it's very much open. So here, here we are trying to solve closed domain and open domain problems. Specifically in open domain problems, now people we spoke about machine learning and deep learning in the recent 5, 6, 7 years, or only recently we have moved into generative AI. Even then, machine learning and deep learning, we cannot forget it, and we require its usage, otherwise clustering. So, to solve open domain problems, is learning alone sufficient? Learning is not sufficient, because if you try to learn the entire open domain data set, a small data set is very easy to train. If you consider a web page retrieval problem, and if you're using a machine learning or a deep learning model for that, training itself will take 365 days for one data set which I used, which was downloaded or crawled from the web. That maybe about 10% of the 1% surface web was taken, only the upper cover, but the training said 365 days. So it's extensively difficult. Machine learning or deep learning models are capable of learning every possible entities and relationships. However, it's not easy to train. So henceforth we require machine intelligence when compared to machine learning, machine intelligence with reasoning or assertional inferencing. Now coming to machine intelligence, is nothing but machine learning plus any AI model is equal to machine intelligence. So any AI model can be a classical or a traditional AI. Maybe like the A* problem or the AO* problem, or any sort of traditional algorithmics, maybe the Robin Carp, string matching. So all these things are the traditional, extremely traditional AI. Okay, the best first search, uniform cost search can be applied for certain problems. And then then the next generation of AI was statistical AI, where statistical models like the Bayesian theory, Markov chain model, decision theory was encompassed, or utility theory was encompassed, wherein a strong encompassment of statistics was seen along with the with any other model, and then any other AI model. In this case, for machine intelligence, we require learning plus any AI model. But traditionally, statistical AI were either used independently or they were used with other existing AI models as a traditional model. Then we came into heuristic AI. Normally, heuristics was used when NP hard problems were encountered, which were not be able to to be solved by using the traditional algorithms. And henceforth, there needed to be representation of the states. A state space was required. Apart from the mathematical space or the Euclidean space or the vector space, a state space was required. And because of the state space, automata theory, as well as state representations, based on Turing machines, where it was encompassed, heuristics were formed, because one solution can lead to many sub-solutions, and each sub-solution can converge at one solution. So heuristics was in place. Further to this, there was meta-heuristics, which came much later, which has a supportive theory. We call them as optimization models. For meta-heuristics, we require supportive theory, like behavioral theory, like nature-inspired meta-heuristics. For example, we had the ant colony optimization, lions optimization, or we had the dolphins echolocation algorithm, or we had the particle swarm optimization. So meta-heuristics means one behavioral theory. It can be nature-inspired or concept-inspired. Concept-inspired, like the gravitational force theory, river formation dynamics, again geology-inspired. Gravitational force theory is physics, and physics-inspired basically. Mathematics-inspired, meta-heuristics models are also there. So this clearly means a supportive theory is required. It can be nature-inspired and non-nature inspired. And again, it has got several solutions you get out of a meta-heuristic, and the best solution will be obtained by running it iteratively or based on the needs. And a objective function or a criteria function or a cost function is a mandate for a meta-heuristic, unlike the heuristic, which always require some polynomial derivation at one point of time. Further, we came to the learning-based models that everybody knows, even the non-computing people know: machine learning and deep learning. So a data set will be given, you have to train and test. But how much can you train and how much can you test? Is the question now. Small domain, very compact domain, very easy to train and test and get the results. Very extensively large domain, very difficult to. And that's why learning-based models are good, but not ideal. So what is semantic AI? Semantic AI is the talk of today's topic. Semantic AI means semantics. Semantics means rules. Semantic AI is any AI. It can be a ML or any AI. So any AI model, along with mainly the hero of semantic AI is the crux of semantic AI, the kernel of semantic AI is not the AI technique, but knowledge, but facts. Inferable, representable facts. These facts, which can be used for inferencing or inferential learning or reasoning. Using any sort of statistics or semantics. Semantics can be heuristics. It can also be statistics. It can be any sort of applicable rules along with knowledge. So rules plus knowledge. Or AI technique plus knowledge. AI technique can be any of the above mentioned AI techniques. That's semantic AI. Explainable AI means you have to break the machine learning and deep learning's black box, because machine learning, in deep learning completely it is black box. You know what goes inside, what comes outside. But the internal computation of how the training happens, nobody knows. We have to break the deep learning model. Machine learning model, the feature selection is known, because machine learning is feature selection is controlled. In deep learning, is feature selection is auto handcrafted. So the features which go into the model is known, but again, what happens within the model, we try to break, but it's not transparent. So that's henceforth. So machine learning and deep learning have limitations, and that gave to rise to the explainable AI. And today we know the generative AI. Generative AI is nothing but transformers, made into LLMs or large language models, and then they are used for generation. We'll talk about that in one or two slides in the very end. So so we are mainly focused on semantic AI. As I told you, the crux of semantic AI is knowledge. And of course, there's something called as fair AI. Fair AI, means hybridization of semantic inferencing and rules. ML or DL models, reasoners have required, statistical AI have required knowledge of factual assertions. So fair AI is one which is feasible, which is ethical, and which is computationally reliable. So this is a completely different topic. Let's not get into that now. So semantic AI was explainable AI, as I told you. So we just finished with this. So semantic AI means conventional AI, statistical AI, heuristics, meta-heuristics, ML or DL models. Any of these models, either it can be plus or it can be even or. But the mandated part is the knowledge. Without knowledge, semantic AI will not work. Explainable AI, we have to break the computationally difficult to break machine learning and deep learning models. Or we can also say that because they are black box, or we can eliminate the usage of deep learning or machine learning models. If deep learning gives 99.9% accuracy, if you are able to achieve 99% accuracy without using deep learning by using conventional AI or knowledge or semantic AI, that also is a basis for explainable AI. So knowledge is what I was talking about. So knowledge is nothing but info. We had data. Data was processed to get information. Information, when reasoned out with some cognition, it becomes knowledge. So reasoning can be mostly human reasoning, because that is called as cognitive reasoning. And now machine can also reason out. But machine reasoners are very, very, very limited when compared to human reasoning. So we call that reasoning as what? Cognition. So knowledge is nothing but needs to be verified. At least the information generated, machine synthesized knowledge. Even today, it requires moderation by humans, and that's called as what? Human cognition. Only a verification is called as human cognition, and is done by domain experts. Every domain has got domain experts, and one of the best examples is our Wikipedia. It's crowdsourced. Wikipedia is crowdsourced. Community contributed, community verified. Contributor is a community person. It can be a domain expert, but again, it is moderated by a community at large. That is Wikipedia. So Wikidata also is the same. The Python version of Wikidata derived from Wikipedia. So it has got concepts, subconcepts. It has got a lot of hierarchy. Then we have linked open data cloud, LOD cloud. You can just access it using linkedopendataCloud.com. It's a project which clearly synthesizes the world knowledge as a single large knowledge graph. Then we have Google's knowledge graph API. It's very common knowledge graph, API of Google, which yields knowledge graph for the entire world knowledge. The knowledge graphs and subgraphs. Then we have DVpedia, NEL, Yago, Commons, CYC. These are all community contributed, community verified knowledge store repositories, also called as what initially they were called as knowledge bases. And some of them are so Google's knowledge graph API, even Amazon, the metadata which it synthesizes is built on a knowledge graph in their servers. It's not public, but however, they have all of this use knowledge graph. Wikipedia uses Wikidata. The principal concepts are highlighted like this into a single large knowledge graph, and all these companies have used knowledge graphs. So what is a knowledge graph? See, knowledge graph is domain knowledge representation. Do we only have knowledge graph as the structure? No, we do have many different ways to represent. We'll talk about knowledge graph because we just have another 15 minutes time, I suppose. We started at 6:15. And so structure, representation of facts, collection of facts about real world concepts represented as triples. That is, we have the entities. H and T are head and tail are the entities represented as nodes in a graph, and R is the relationship between them. So always there are two nodes and one relation which is giving this two nodes, which is linking A9 and Amazon. Subsidiary means in ontology we use subclass of. So A, B, and then you have we have a link between A and B, two nodes and one relationship. and this can be a knowledge graph. Clearly, we can see, okay, both Steve Jobs and Steve Ballmer, okay, are located, okay, they were a part of, okay, the US, and both, okay, were associated with, Steve Jobs was associated with Apple, iPhone. Palo Alto is where it is headquartered, and Steve Wozniak was his colleague. Similarly, Steve Ballmer, he was associated with Bill Gates, Windows, Microsoft, and Seattle. So some, okay, concepts between, okay, where he was associated, okay, and some concepts between where he was associated, and both are linking to a common concept, a very, very, very abstract representation of a knowledge graph. Okay. And what makes a knowledge graph? Not every data in graph format is knowledge graph. Citation networks, web graphs, road network are not knowledge graphs. Knowledge graphs means there is a well-defined, okay, terminology box and an axiom box. Terminology box is nothing but the real world concepts. Okay, in OOPS here I learned about the classes. In ontology, it is nothing but we call concepts and sub-concepts. So from an ontology, any specification in real world, any vocabulary, okay, which has got independent existence is a concept. And okay, a concept can have, for example, a vehicle, okay, is a concept. Vehicle with 2 wheels, vehicle with 4 wheels is a classification, is a sub-concept. Vehicle with 2 wheels can be a bike or a moped or a bicycle. Again, that is a concept. Okay, a bike can be a specific model. For example, okay, Apache RTR 160, that's a specific model. So that becomes what? It becomes an individual. So last level is the individual for an ontology. Okay, so it has to have a terminology box, basically ontology, and an axiom box. Axiom box represents the facts, statements, or at least the relationship. Okay, at least how, okay, see, concepts and the relations are evident in the terminology box, and axiom box represents the linking of them, the rules. For example, okay, this may be a little controversial, but it's okay. The Rahul Gandhi family. So Rahul is a male, Sonia is a female, Priyanka is a, so is a, has a, is a part of, has a part of, is a subsidiary of, is a, okay, super class of, is a subclass of, okay, is the associate of, they can be the relationships. So Rahul has mother Sonia, Priyanka has mother Sonia, right? So a T box, this is the specific, okay, axiom box. T box is the very generic ones. Person, male, okay, female. Okay, that's what is it. Person, male, person, female. Okay, is has, okay, so that kind of a relationship is between them. Okay, so commonly used knowledge graphs, we have Google, Bing, Yahoo, Yandex, DBpedia, Wikipedia, Yago, CYC, and many we do have. And okay, so how exactly? Okay, so from the real world, okay, Web 3.0, today's web is transforming towards Web 3.0. From the current structure of the web, okay, only 4% of the web is accessible today by the search engines. 96% of the web is not accessible. Okay, it is the deep web. Okay, in that 4% of the web, 150 million zettabytes of data is present as per 2008 statistics of Google. After that, they could not take any 2018 statistics. After that, they could not take any statistics. So signals, so anything, okay, the real world data is created as knowledge. Okay, and this knowledge is finally refined as a knowledge graph, and these knowledge graphs can be used by any application, mobile apps, etc. Okay, so knowledge discovery, we have to understand the domain and reason out. That's what it is told here. And for instance, okay, from a very nominal data available, a document itself, clearly it's seen that Barack Hussein Obama, that's Obama's okay, actual full name. He's an American politician, but what's he? This is a write-up about Obama. Okay, maybe from his his bibliography or somewhere they've taken this. But again, what has happened is the important terminologies. First, indicating the person, indicating his ethnicity, indicating his he's a politician. Who should indicate to him? He grew up mostly in Hawaii. He should also indicate to him. Okay. So Obama and Barack Hussein Obama indicates the same person. That's called coherence resolution. Okay, it's an NLP concept. So okay, whatever it is. So important. Okay, contents of him is highlighted from a very large data which is available. So these important concepts can be clearly made into a knowledge graph like this. Okay, for example, Obama supports military action in Libya. Albert Einstein was born in Germany. Subject, predicate, object. Even our ontology is given as subject, predicate, and object. Okay, so subject and object are the two different nodes, okay, or two different entities, and predicate is the relationship between them. For example, okay, Scotland opposes Brexit. UK supports Brexit. Pulwama attack targets CRPF. Pulwama attack orchestrated by JEM. So these are all facts about people, movies. It can be any domain, any real world domain. It can be events, it can be opinions, it can be facts about any subject. It can be the last talk was on civil engineering. It can be on civil engineering, electrical engineering. It can be any domain. It can be artistry. It can be paleontology. It could be anything under the sun. So how good is the knowledge base? Knowledge base was a very, very initial representation with subject, predicate, object alone. Then this knowledge base, okay, came up into, okay, knowledge bases came up into, okay, ontology, which we'll be talking about, and then we got the knowledge graphs. So basic initial knowledge bases were opinion based. People's opinion were encompassed with newspaper articles, Wikipedia, and debate. Debatepedia is another web source like Wikipedia. Entity extraction techniques was okay. Yago was okay used okay for entity matching. Phrase extraction was there. Basic NLP techniques was used, and then relation extraction was either support or oppose, because it's again an opinion. They support a debate or they oppose a debate, and the refinement was done. So similarly, techno base for okay, it's a tech based knowledge base, biochemical knowledge base, event basis based on events. Biochemical again research articles were there. Brenda is another repository, okay, for biochemistry, okay, so on and so forth, where okay encompassed experts. Entity extraction was here, expert curated list, web sources, POs again NLP techniques, heuristics from the research articles were also encompassed. So very clearly there is okay some techniques. So then how the relations were extracted, refinement, the sources. Okay, and this is a event based, biochemical knowledge base, techno base, opinion bases are all existing knowledge bases. Okay, and this is how they were designed. So for other okay domains, also civil engineering, electrical engineering, we can develop knowledge bases, knowledge based development, knowledge based engineering, knowledge based synthesis, ontology modeling, knowledge representation and reasoning itself is a okay area for research. Very clearly. Okay, so opinion based had opinion. This is how opinion based look like. Let me not get into the details. Okay, this is how opinion based gave rise to opinion network. Okay, clearly opinion based just gives the tabular representation or a RDBMS representation, whereas opinion network gives a initial a graph based where the topic hierarchy is on the top, the entities are much in the bottom, and the faces are in between. Okay, so initial topic, then much more refined, okay, refined material, and then entities are, okay, could indicate okay various repositories and detailed material. So then opinion okay network got okay gave into an opinion NELT. Okay, that's a different okay, that was actually search engine operated on opinion network. And okay, so that's about the opinion network. So canonical names were extracted, candidate extraction happened, and the hierarchy was constructed. Okay, and then a techno base was also built. Okay, where Wikipedia, Webopedia, okay, online textbooks were because it's a technology base. So textbooks are required because textbooks have the keywords, glossary, index, a very rich source. Webopedia and TechTarget are two applications which are already available. Wikipedia, we all know. So these many okay entities were extracted and then merged in order to create a large okay knowledge base for technology. So it had okay a type of, it had subtopic of, application of, algorithm for, and technical are the major relationships. Okay, RDBMS was followed, and then okay further okay applications were built. Statistics were this: unique entities about 70,000 plus, relations were 2,500 plus, triples were about 146,000 plus. Synonyms, terminology, type of, subtopic of, concepts in, entities, relationships, and triples. Again, this is Wikipedia, this is Freebase. They were also merged with Technobase. Henceforth, okay, these many number of entities were available along with this, which was merged later. For biochemical paper, okay, this is the this is a Brenda was used. Source Sinobase, Microbes Online, again a portal, Meta Microbes Online, Pub MLST, okay, Genome, etc. So this is how knowledge was built. Okay, let me just fast forward this. Apart from this, XML can also be used. XML is tags for structuring the data. Okay, XML can be used because XML, metadata of XML, XML DTD, XML namespace, is mainly used to build the RDF, Resource Description Framework. Okay, and ontologies was built on XML. The web ontology language or the ontology web language was built on using an XML namespaces. So ontologies are nothing but any vocabulary. The best definition of ontology is explicit, shared explicit representation of a shared conceptualization. Formal explicit specification of shared conceptualization. Formal means a formalism is given, explicitly represented. Specification is it is specified, of shared. Knowledge is shared. Conceptualization means the concepts or the classes of the real world. And ontology is shareable. Ontology is representable. So ontology again has what? Okay, a concept, sub-concept hierarchy. Okay, concept, evokes to a symbol, refers to a thing, stands for a thing. It can be anything. See, a jaguar can be a concept, a car. Jaguar can be another concept. It can be an animal. Okay, so that's how an ontology. So we've seen many things. We've seen ontologies. We've seen knowledge graphs. Okay, we've seen knowledge bases. Techno-based was knowledge bases, and knowledge bases giving rise to networks. Opinion base give rise to opinion network. Okay, these are all knowledge representation schemes. The most basic being ontology. Now we saw about the representation schemes. Now let's see how. Okay, so ontologies can be reused, can be obtained. Once represented, it can be hosted. Okay, one of the places is unspsc.org. You can get ontologies for so many different portions. Okay, so many different topics and subtopics. Again, in Swoogle. Swoogle is Google for ontology. Ontology also gives what? Metadata. Okay, it is one of the contribution to metadata. So only ontology, or you want vocabulary, or you want dictionary, or you want all, you can search using Swoogle. Okay, almost all real world domains you have it already. You can improve it and you can host it. Okay, and how to use it? This is until
Deepak, another 2 minutes, Deepak.
So yes, sir, it's done. Until now we saw about knowledge representation and reuse of knowledge. Now let's see how can we do quantitative reasoning. So another 3 minutes. Okay, I'll finish it. Okay, so very clearly, okay, this is a search engine. Okay, for a real world search engine, but for this highly inter-domain linked ontology of knowledge was used. Okay, from the query was pre-processed. Sparkle agent was used. Freebase again came from the World Wide Web. A repository of knowledge from their RDF was used. RDF is subject, predicate, object. It's basically an ontology. Predicate was dropped because it links subject and object for computational feasibility. Subject and object was used. Term frequency matrix and term concurrence matrix was formulated, and then singular vector decomposition, term prioritization vector was used, and then the best fit estimation algorithm was made use of, which had a lot of semantic similarity methods like this ENAPMI. It's again statistics, which uses the pointwise mutual information between two concepts, individual occurrence and the co-occurrence of the two concepts. And it uses the adaptivity coefficient, and which also uses a drift index. Logarithm of the probability of the individual occurrence of the two words, and the probability of the co-occurrence of the two words to entirely make sure that the search is reduced and a term vector is easily converged. So this is the quantitative reasoning part. We can use any sort of statistics like semantic similarity measures. We have the second order co-occurrence PMI, we have the cosine similarity, we do have Jacquard similarity, we do have Simpson's diversity index. Clearly we can see the diversity index was used where the entropy was basically used along with the semantic drift. So this is how reasoning is done. Knowledge is curated, knowledge is used, and reasoning can be done. This is all done based on thresholding. Okay, if it's a statistical measure, 0.75, 0.85, empirical reasoning can be done. If it is a index, like symptoms diversity index, okay, there's the difference between the current and the next value. Okay, that should be less than 0.15, 0.12. That is called as step deviance, is chosen as the key. There are many indices. We have modified Simpson's diversity index here, but we have Horn's index, we have Morristra's overlap index, we have the Lloyd's index, Lanson-Williams index, we have the Bose-Einstein's index, and many other indices which can be used. And this is how it was implemented. We use protein ontology ontology modeling, freebase, semantic wiki. A dataset was MSN BEC, queries were 120, 152, ground truth was 148, and gate was used for all the NLP techniques. Okay, and very clear. Fact plus was used to confirm the domain deviational constraints. And finally, OntoCollab was used for dynamic modeling of ontologies. Okay, finally, this many domains, subconcepts, individuals were used. Okay, our algorithm was curated, and clearly see in Google, when you play, at that point of time when I did this, Apple only, when you have to sign out, only, okay, the prioritizations which came was Apple iPhone, India, watches, nothing about anything else. But here you can see a full cover search. Apple Pie, Apple Inc. If you click, you get
Deepak, another speaker is waiting. Deepak, sorry.
Yes.
Please find out.
Okay, so this is how you use the knowledge. And further to this, okay, LLMs. Okay, so the knowledge graphs or ontologies are there, large language models. Okay, text corpora we can use to train the large language models. You can use as the features to, okay, the machine learning and deep learning models. So this is how it can be used in the LLMs too. Thank you. I'm done, sir. Thank you so much for the patient listening. Hello.
Yeah.
Yes, sir. I'm
Thank
done.
you, Deepak. Very informative. Sorry for the
No problem.
We have
No problem.
I think we were not able to cover in detail.
No, it's fine. It's fine.
Yeah. Still, thank you very much for your time.
Yes, sir.
And on behalf of all our directorate and commissionerate and secretary, thank you for your valuable time and sharing your knowledge with us.
Thank you so much for inviting me. Thank you so much, sir.
Yeah. Next, we have a distinguished speaker from industry, and is actually happens to be the student alumni of Government SKJTI and the student of mine. I'm very proud to introduce to this gathering, and is Mr. G. Tejas Kumar, and is a software engineer at the company which actually is working now is we have with us Tejas Kumar and one second. He's working at Softnautics, my MOS chip company, Bangalore, and he'll be delivering a talk on hardware design, the microcontrollers, microprocessors, sensors, and actuators, and the communication interface. Tejas, are you there?
Yes, sir.
Yeah. On behalf of all the participants over here, I welcome you, Tejas, for this AROHAN series. Now I request you to please continue your session.
Yes, sir. Thanks for the introduction, sir. That means a lot. Yeah. Good evening to one and all present here. Myself, Tejas. Here I'm presenting you about embedded systems for industrial applications. So here today's topic for mine is embedded systems. So the first question which arises is, what is embedded systems? So everyone are aware of what is embedded systems, but I would like to give a quick review of what I'm about to talk, or what exactly the embedded system means. So here, if you see, embedded system involves every single object which has a small kind of processing, like let's say microcontrollers. Any microcontrollers which we are using around us, let's say we have a car, and we will be using a Bluetooth connectivity, which internally takes the packets of Bluetooth and then decodes it, and we get the data, right? The same goes with the phones. Okay, I'll come back to the phones later. Same goes with cameras, same goes with airplanes, helicopters, and small, even gaming devices. Let's say even a CCTV camera, which can be streamed your house to your wherever you're staying, like from phone or somewhere. So the streaming or some kind of small kind of processing is involved in this embedded systems. Even the printers, for that matter, uses embedded systems. Even the phones. Why I bought the phones? Even you can say phones are more complicated. It can do a perform high level tasks. But how is it embedded system? Yes, it is embedded systems because it uses ARM architecture. ARM architecture is a controller's architecture. So we do have two architectures. That is, I'm just giving a try, trying to give a quick review. That is, we have two architectures. That is 8086, x86 we call it. That is our laptops, systems, everything we use. And second is the ARM architecture, which we use. The ARM architecture is small devices like our phones, washing machines, or anything as such. So today and presently I'm working in the field where I'm working for ARM Cortex M33 core. I'm presently I'm working driver development for all the peripherals of ARM architecture M33 core. So I would like to say what exactly ARM architecture is. So here is the architecture, SoC architecture of ARM. Let's say who did this. There is already a standard where all the ARM architecture does follows this. So any mobile, anything you take or any embedded systems you take, they have to follow any controllers. If they say it is ARM architecture, that means they are following this basic fundamental things which are present in the screen right now. See, everything we know that we have a processor and we know it's a RAM and we know DMA. I think all this are clear. I'll revisit all this. What is this processor? Processor just does the computation part. That's it. And we have AHB, that is high performance peripheral bus and high performance buses. This buses has 3 lines. This is a basic recap what I'm doing very fast. ARM controller does do the computation. Buses has 3 things. That is, one is address line, control line, and data line. So all these are connected with address line, data line, and data line, address line, and control lines. So all these are connected here. So major part here is already the architecture itself is designed in such a way that everything has its place. Let's say this is the ARM architecture. So here we have a bridge. Then here comes the peripherals. Why I'm talking about the peripherals or the modules is because this is how the ARM controller interacts with the external world. Let's say this peripherals is the key point to the external devices. How do I put is the ARM architecture does this ARM processor core will do the processing, the data and control bus will see where the data is coming in or coming out. Data lines will be 32-bit. If it is a 32-bit machine, it will be a 32 lines. 64, it will be a 64 lines. And the address, where exactly the address, which address to be written or write. So we have EHB as that is a high performance, that will be in high speed. So ultimately, this architecture is already standardized. But what we'll be touching is this peripherals. Using this peripherals, we will be interacting with the outer world. That is outer world. I mean, let's say we have a sensor, some sensors like this. This will be interacted through a peripheral. Let's say these peripherals I'll be talking today. Today's concept is this. Let's say now I have I2C, for example, I2C, or some other peripherals similar to this. These sensors, how we are interacting, or what is the medium of communication between these two, which is it? Sensor and the peripheral in the ARM architecture. Okay, so let's go. Okay, whatever I said, AXI, extensible interface. Okay, in this bus, AHB bus, we can have AXB bus also. This has 2 read and write channels, which will be fast because read and write can happen at the same time. Then we have ABH light channel. I'm talking about this again. Instead of this bus, we can have ABH light. So ABH light, what it does, it can only support 1 master at a time, single master, but read and write doesn't happen as AXI. ABH light doesn't, or ABH for matter for both this can only do read or write at a time. It can't do read and write together. So that is why the importance of AXI is here. And this is this design, whichever we can select based on our cost, because AXI is costlier and this AHB and AHB full is cheaper. AHB light can do read or write at one particular time. It can only do read or write, not and write or write. But the catch here is it's a single master. AHB full, if you come, it is a multi-master. It has a multiple master. It can serve multiple master. The only difference between all this is the performance and the cost. So the whatever I spoke just now was just this part. This bus, whatever black line you see, the dark, can be selected for the architecture. This can be done VLSI before the fabrication of the microcontroller. Okay, then comes the real-time clocks and watchdog. Real-time clocks is to have a clock internally ticking for every, let's say we have 32 megahertz clock. That simply means in 1 second it ticks 32 times. So 32 mega times, that is 32 into power 10 power 6. So whenever the clock ticks that much, that's 1 second. That's how the clocks are there. And watchdog is something to do with, we start a watchdog and we keep feeding the watchdog. If we don't feed the watchdog, the computer system resets. So people will be familiar with watchdog. It is just to make sure that something is not hanged for more time. So now where I want to stress today is how exactly these sensors interact. So how do sensors interact in embedded world? How does it happen? Let's say the sensor is connected to a ARM controller. I'm talking the case where sensor is connected to ARM controller through lines. What can it be controlled? Like example, this is the processor. This is a microcontroller, whatever you're seeing in the screen. And this is wirely connected. This sensor is wirely connected. So what are the possible ways we can connect this particular sensor to our peripherals? To this thing, whatever I said, I2C is a peripheral. So one sensor can be connected any way we want in these peripherals. So I'm talking about these peripherals. What are the options we can connect? And why do we have so many options? When sensor is connected to one peripheral such as I2C, then why do we want one more peripheral SPI? So all that I'll be talking today. So how do we interact with two sensors? So there comes the peripherals. So here you can see the peripheral term. As I said, I2C, I just wrote it in the first screen. So this I2C, if you see, I just wrote it in the first screen. This in the whole ARM architecture, you can see that I2C is in the whole ARM architecture. I2C is just one part I wrote, and I wrote a sensor connected to it. So like that, in the place of I2C, we can have SPI, XSPI, SDIO, UART, PWM. These are all the mediums we can connect a sensor or get data from external world. Okay, what do you mean by sensor? The sensor itself means that it senses something and tells us, right? So this is the ARM architecture, the box which you see here. From here, there will be some lines out. From there, you can connect sensor and get. And we have I2C lines, SPI lines, all those things. So these peripherals are, why I'm telling this is industries, in the field of industries, so wherever I'm working, I've switched to companies. Everywhere, everything will be interacted through this. Ultimately comes down to this. So anything, if you say, let's say I'm not connected to wire-wise, I'm connected to Wi-Fi stages, then where does this SPI I2C comes? That time comes the SDIO. This is something to do with Wi-Fi. Once this is up, so other devices which is connected through Wi-Fi, through cloud, this can be accessed. So SDIO controls Wi-Fi, Bluetooth. So these things, I2C, SPI, XSPI controls the wired connections. Let's say we have a controller and we have direct connection, connected a sensor in the same board. Okay, so let's go to the peripherals one by one. Okay, before telling this, I would like to give a quick review, like a quick known how this peripheral also are designed. Like how do you write something or how do you configure these peripherals? Simply, all the peripherals are memory mapped. Every particular controller will have the data sheet where it tells the base address for all the peripherals, just like this. I have just given an example of an M33 Cortex controller where it gives the example like this. This is just an address. What do you mean by address? Like it's just, no need to complicate it. It's just simple. It's just an address location in the, that is the address for this. Let's say it's a UART base address. This is the base address. If it is GPIO base address, this is the base address. So this is how you reach for this guy. See, ABH is there and you have to reach for UART. Then what you have to do is just know this address. Okay, you'll ask me the next question. I know the address. How do I access it? It throws back us to the simple concept of C, that is the pointers. You just have to do this address as a pointer and just access that particular value. It will directly reach you out to the GPIO. This is what we can in industries or every other standards we are using in embedded ARM architecture, Cortex M33. That's how I am developing even presently. The drivers are developed, the applications are developed. This is how the whole industry works, and this is how they have generalized things. So they are giving the base addresses for each peripheral. And you can ask me, there is, see, let me take, here there is 2000, 20,000 last, right? But that is not, next is not something like 20001. Why is the difference so much? Because each byte, let's say in the next byte of this is 0x400 200001. The last bit will be changed to 1. Why is that not involved as UART? Why? Because from this to this, how much of a bytes we have, how much of a memory addresses we have, that will have a meaningful message or the way to write to that address to access this GPIO. So GPIO will have so many functionalities. Each functionality will have address, and we can access it with normal C code just by accessing the base address, that is the first address, as a pointer, put it as a pointer and access it. If it is a next address, just you know the address. So the next address will be +1, and you have to read the data sheet what each address means. This address means what? Let's say I write to this address, if I write 1, what it means. If I write 2, what it means. If I write 3, what it means. So each address like this, there are several addresses. That is the difference between one peripheral to other peripheral. So what I'm trying to tell is, how do we set something for a GPIO? Each address will have its own meaning, and you just have to use the concept of C, take that address as a pointer and store that value. So pointers value, you just have to store. What you have to store and what each pointers means, what each address means, that you will get to know in the data sheet of the microcontroller. Every controller will have its own data sheet. For example, even a Snapdragon, if you take the Snapdragon, what I mean is our phones. Our phones also will have a data sheet, and all, let's say you have to access any peripherals, the addresses will be given. You just have to take a normal, even you can just write a normal C file and run, and it will work. How it works is, you have to just read the data sheet and make sure this particular GPIO base, you access this address and make it 1, and see what it means if you make this address 1 and other address. So every single address, the meaning and the values will be given through this GPIO base address. Okay. So same goes with UART, same goes with I2C, same goes with SPI, same goes with all the peripherals what I discussed here, what I'm trying to tell here. So I'm just telling from the country CP or whatever C program we write, it runs here, right? From here, how do you use this ABH bridge or any bridge you're using for your design to reach this peripheral inside the controller? So it's just, you have to know the addresses and just configure and read the data sheet, what it means, each byte or each addresses means. So now I'll jump into the concept of ours, that is I2C peripheral. Why do we have I2C peripheral, and what is these? Now we know how to interact with GPIO or I2C or anything just by addresses, just by having the base addresses shown here. So let's see, what does this I2C means, SPI means, UART means, or GPIO means. I think you should be familiar with GPIO. GPIO is just one pin which makes it high or low. What do you mean by high? High means if it is 3 volts, low means it is 0 volts. That's all. So GPIO is very basic. I hope you get the GPIO base. And feel free to ask me questions or interrupt me anytime it's required. I'll be happy, and I'll really do appreciate it. Okay, let's go to the peripherals. Okay, let's talk about the I2C peripheral. We do have I2C peripheral. This is the, okay, I'll show you this. This is what we have. We have 2 lines connected from the master to the slave. What is the master? What am I specifying here by the master is, I'll go back to the slide where our ARM controller is the master. This is the master. This whole box is the master. Sensor is not the master. Only the ARM controller, what we have here, the box, ARM controller is the master. If you go here, this is the master. What is the slave? Slave is the sensor, whichever sensor you are trying to attach. This is the master, is the ARM controller. Slave is the any slave. Excel. I'll make it simple by giving just a small example. That is, a slave, you can take it as a temperature sensor. Okay, this is a temperature sensor, which is simple, which will only give the temperature value, that is 30 degree, 25 degree, 50 degree Celsius, or something like that. This just gives one number, that is 50, 30, 20, anything depending on the surroundings. It senses the temperature and gives. How do it gives the 20, 30? how does it gives this value to the master is what is discussed here. The slave has the data that it measured that there is 20 or 30 or any temperature value. So it has to send it to master. How does it send? It has only two lines. It has only two lines connected from master to slave. That is, arm is connected to this with only two lines. That is I2C like this. I2C is already there and sensor is connected this way. Two lines are connected to the master. Why only two lines? And why exactly two lines? That comes to the protocol. Protocol. What does it protocol means? Okay, first see what is the two lines. Two lines is just as first is the data line. Oh, we all know that, yeah, data line is most recommended and required because we know the data is sent 50 or 30 or adjusting 50, number 50 can be converted to binary and zeros and ones, you can send it through this line. This line is just one line. If there is a 3.3 volts, it means 1. If it is 0 volts, it means 0. That's all. If you convert number 50 in binary and send it through zeros and ones here, the data is sent, correct, right? But why do we have the clock? We don't want this clock. Why do we have the clock? Clock is required. Why is in a sense, let's say we send high, okay? This master will not know when to read this line to get the data because this master doesn't know. So let's say if we have a clock like this, let's say we don't know when to read, right? Master doesn't know when to read. Let's say we have a clock like this, then master also will get this clock and he'll understand that whenever there is high, I have to read this line. If this line is having 3.3, that means 1. If it doesn't have 3.3, it is 0. So when we have clock, the only way we are having clock here is to know when the master should read. When the master should read the data from the data line. So I think two lines are pretty much clear. If you have any doubt, you can ask me. Data line is used to transfer the data and clock line is used to tell when to read the data from the data line. So this is the protocol of I2C. I'm simplifying because we are running out of time. We have 15 minutes left, so I want to make sure to cover everything. So protocol goes like the start condition, address, then acknowledgement will be done by the slave. Then data is transferred and stopped. Okay, this is done here in the cycles. Okay, next line itself I have where it tells this data is sent in data line during this clock. During this clock, okay. So whenever we have only then the master reads the data. And how do you know master had received the data? So master will pull the data line low to say that, yeah, I have received the data. What it means is after 1 byte of read, master, till now the slave was controlling this line, right? Now when the data is transferred successfully, master to acknowledge, he will pull this line low. He will pull it low. Till now it was being pulled by slave SDL. That is why we have 2 arrows here. So master will pull it low. That means it is an acknowledgement that it got the data. So this is the I2C protocol. If you have any doubt, you can just ask me. This is the normal basic I2C protocol, which is used tremendously for memory read-write cycles, sensor interactions, any internal memory reading. We can even configure internal RAM also in the worst case when we don't have a peripheral to read it as I2C. But the only thing is it will be slow. That is what the next peripheral what we have will come. So the next peripheral is SPI. See, only thing, everything worked fine, right? Why do we want I2 SPI? So if you see this I2C, you can see there is only one data line. Data is transferred successfully. Yes, there's no doubt, but there is only one data line. That means what happens is if slave wants to send the data, it has to wait until master sends. And if the master have to send the data, if the slave is already sending something, master have to wait until the slave sends. So this is half duplex. At the time, it both cannot communicate the data together because there is only one line involved, right? If both start modifying this line, there will be a junk. Like we don't know what the data is. Both expected results or both whoever wants to transfer the data won't be correct. That's why the only drawback of I2C is it has only one line. Let's say that means speed is less when you want to interact with both here and there. Let's say you have to interact very fast, master to slave, slave to master, independently and continuously. That time you will have to move to this next peripheral, which is SPI. If you go to SPI, I'll directly move to the SPI implementations. Like what is the lines connected, that hardware wired lines connected. So hardware wired lines connected here is clock. As we know why we want clock, to know when exactly to read the data or write the data. Here we have MOSI and MISO. What does the MOSI and MISO mean? Means master out, slave in. MISO means master in, slave out. This simply means that master is writing and slave is receiving. Master out, slave in. Master in, slave out is master is receiving, slave is sending. So it goes in line with I2C, but only difference here is the master and slave can send the data independently. If the master also can just send the data and slave also. But here you see the lines. Lines is important. See, MOSI means master out, no? The direction is only one side. MISO means master in, no? So direction is only from the other side. That simply means master, one line is to master to send, one line is master to receive. Okay. You may ask, then one slave is fine. Why we have 2, 3 slaves? We have one slave is fine. We have 2 slave and 3 slave. How is this working? See, the simple concept. We have something called chip select. Okay. So how do we connect slaves in the row to this? See, master will have this many chip selects. So each chip select will be connected to each slaves. Each chip select will be connected to each slave. So each slave. So whenever master want to interact with this slave, he'll pull this line low, and that means he'll make this line ground, 0, voltage 0, and anything that comes and goes will go to the slave. If he wants, then when he wants to send data to this line, second slave, he'll make this high and he'll make this as low. And everything data comes and goes will be to the second slave. And the same goes with the third. If he makes this 2, revert this 2 and make this as high. So only one chip select should be selected. That time, third slave will be selected. Any data transferred will go for third slave. By this, we can connect multiple slave and have a fast communication in and out. So here we have covered 2 things. That is I2C and SPI. What is next? XSPI. What is XSPI? So XSPI is again the extension of XPI. What it does is we have 4 lines here. The only different XPI we had only MISO MOSI clock, right? But in XSPI we have 4 lines. We have clock, as we know. We have chip select. Chip select, same concept goes here also. If you have multiple slave, if any chip select is made low, that particular slave will be interacted. Same goes with this. Same goes with this. Okay. The same concept is here for chip select, but only difference here is instead of MISO MOSI 2 lines, we have 4 lines. We can use these 4 lines however we want. Okay, I'll tell what do you mean by however you want. Here, MOSI and MISO, see, since the direction is this, let's say we have connected this master to this slave this way, this fashion. But the problem is, let's say master have to send too much of data, but still he has only 1 line. Even though the 2 lines are connected, we are not utilizing the other line. We are just keeping it to the slave to send something, right? There comes XSPI. What it does is it has 4 lines. You can use that 4 line any way you want. Let's say you can use the 4 lines from data to slave. I can use the 4 lines from slave to master, or I can use 2 lines from master to slave and 2 lines from slave to master, or 1 line master to any combination of 4 lines with any direction is possible in this way. So this QSPI or XSPI can be used this way, all the same concept. So we are just seeing I2C had 2 lines, and SPI had one line for data. SPI had 2 lines for data, and XSPI had 4 lines for data. But this has the what is it? It has a control to control all the 4 lines data transfer in and out. So you can use all these 3 methods to send the data from sensor to the ARM controller. The first slides I showed you. This all whatever I said, SPI and XSPI will come into this level. The same goes here. The same peripheral goes adds on. Okay, the same peripheral. So we can use the wired connection from slave to these things. These are the wired connection. Next comes, let's say I'm using the wireless. What do you mean? The wireless, what do you mean is the first thing what comes in the wireless is the Wi-Fi modules. Wi-Fi modules, even that, when you go for OSI model or any hardware level 0 model, in the model level 0, like level 1, it will be coming from bits. Okay, so if you go for that model, Wi-Fi data will be coming from 0s and 1s, and that will usually come from the SDIO interface. What I'm talking is internal to ARM. Nothing to do with the external Wi-Fi. What I'm talking is we have a router here. Let's say we have a router, and this is the ARM architecture. That this is some ARM, okay, some ARM device, okay, and this router is sending to. This is SDIO. Please bear with my handwriting. This is sending to one receiver here. Again, hardware level receiver is here. Okay, hardware level receiver is here, and this from this receiver we are getting in SDIO. Fine, this is how it is, and this SDIO comes with this is hardware level receiver and this SDIO. So SDIO is usually for any Wi-Fi data. That's how we are having. That's why we have that peripheral. And this same SDIO can be used for SD card also and Bluetooth communication also. All three things can be achieved in SDIO because of there's something called something in this. This has some all similar to QSPI, but only different here is the command. You can see clock is here, data 0, 1, 2, 3, 4 is here, and the new thing added is command, and the one thing removed is chip select. We don't have chip select here in SDIO, but we do have command. We have different command for let's say if it is a Wi-Fi data, we have a paper on this IEEE paper which tells the SDIO the standard how it have to follow. So the data lines here can be used in different ways. That comes in command. Depending on command you give, the data can be taken out. I worked on this also. We have, if you quickly summarizing, for SD card, it will be CMD 17, CMD 18, CMD 24, CMD 25. These are the commands. So whatever names I said, CMD 18, CMD 17, these are just the rules to use these 4 data lines with the clock to get the SD card data. If you want to get the Wi-Fi data, there is something called CMD 53. If I had time, I would have explained CMD 53, 17, 18, 24, and 25. We're running out of time. So I'm just trying to tell you, I'm trying to give a quick brief that these 4 data lines with clock line can be used for SD card data. SD card, in a sense, you can store your images, files, anything can be read. That uses something called CMD 17. CMD 17, 18, 24, 25. Okay. Then comes if you want to read something from Wi-Fi, Bluetooth, or the Wi-Fi Bluetooth. Yeah, Wi-Fi Bluetooth as a major things. Other things you can still use for other functionality. You can just create your own group and send. That uses CMD 53. What is CMD 53 means? Simply the combination of this data line clock line to use to get the data from the receiver, whichever I showed. I'll just show you. The first, whatever I showed, this receiver will get from SDIO, right? This data, how to get it or how to send from year to year. That is what SDIO means. Okay, this is the receiver. That is SDIO. Next comes the UART. So UART, if you see UART, we have simple things. UART is some simple, very simple. You can say UART is like you would be using Teraterm or Miniterm or Minicom. This all uses UART. UART has very simple things. This only has 3 lines: RX, TX, and ground. Same goes here also. TA. This is let's say this is ARM. Okay, this is our controller. I am done with the these things. SDIO Wi-Fi things comes here. Okay, again when you come for UART, UART is a lined connection. What do you mean by lined connection? Literally the lines should be connected. That is why we connect a Teraterm. Whenever you connect a USB, the lines, these lines are connected internally. That is why you get Teraterm only if you connect the USB. That's very common sense, and we know that. But I'm trying to tell, what I'm trying to show is the UART protocol is used with wired. Okay, this is all used for wired communication. So here you come RX, TX, ground. As name suggests, it is very simple. RX is when you want to receive. This is ARM and this is sensor, or any other data, anything can be a sensor. Okay, this can be a sensor and any other peripheral or any other things coming from your receiver, anything. Okay, this will send, whichever this sends, it will go in TX and it goes this way. So the sensors TX will be our controller's RX. That means sensor, whatever sensor is sending for a, we have to receive. That is why this is cross-linked. TX is connected to RX. Again, if our ARM controller is sending something, that will be a TX that will be received by the sensor. That's all. Okay. You can see the and ground. To have a common ground, we are connecting ground. This is very simple. You can ask me one question. What would be that is, we don't have a clock here. You have seen every single peripheral till now, we have a clock. Clock here, clock in XSPI clock, data lines changed. Here we have MISO, MOSI, one line for master to out, master in, clock is here. I2C also clock is there. Then you will say, when exactly you know when to data to read? That's a basic question we asked, right? When we were in I2C. So how exactly, when exactly we are going to read the data? How will know when to read the data? The solution is here. Exactly what it is we have something called baud rates. If you're using Teraterm or anything, your data will be junk sometimes if you don't set the baud rate. You all would have experienced this. If you open a Teraterm and try to read something, we would have got the junks, or we would not get the data. Why is we have something called baud rate? Okay, what is a baud rate? Baud rate is simple. There is an internal clock running in this side and this side also, and both agreed upon a clock. Both agreed upon this clock. Both agreed upon this clock. So that's why when the sensor or other medium is sending in one baud rate, we have to receive in the same baud rate, because both the basic function of this UART is that both are aligned and both have agreed upon having the same clock. That is why the baud rate concept is very important in our UART, and we have the baud rate only in case of UART, because we don't have the clock line. That is the justification for not having a clock line. Clock line is not required. We both agreed upon one clock, and we both receive, and we'll be continuously monitoring this line in that clock phase. Okay, both the lines will be agreed upon my clock phase. Okay, next comes the PWM, and the last peripheral I have kept for the day. We still have many more peripherals, but I kept for this just to make a quick glimpse of how it works. And I think other peripherals can be known by downloading IEEE papers or just by Googling at the data sheets of that particular protocols. You can just read, and every single, whatever I explained will be explained there, but much bigger file with a bigger picture. Okay, PWM is simple. PWM, what you mean by PWM is simple. We have only one line here. This is the 50% duty cycle. This is the 75% duty cycle. This is 25%. It simply means how this only one line connected, and that line how it want to be, this like this or something like this, very largest. So it all depends on this. This is called duty cycle. 50%, 25%, 25, 70%. Why is this duty cycle required, you can ask. Let's say now we connect a light to a ARM controller. Okay, let's say we connect a light to a ARM controller. We have a light sensor. Okay, sensor, this is light, just one single light which works on 3 volts. Okay, let's say you want to make this light glow from low to high and high to low, smooth transition. That's smooth high and smooth low. That cannot be possible using the voltage line 3.3 to 0. If you make 3.3, the light will be high. If you make 0, the light will just go off. So in that case, what you do is you give light and take light, give light and take, give voltage, give voltage and take voltage in 50%, the light will glow in 50%. If you give duty cycle is 75% on and 25% off, it will be 75% glowing. If you do 25% on and 25, that time the light bulb or light, whatever you're connecting sensor, that will glow in only 25%. So this peripheral can be used to control the voltage, like overall voltage. This will sum up and come up to overall 25% light only. So the light will glow very low. So this is how it is, and it is used in LED light dimming. So this is the actual word, LED light dimming. And motor control, yeah, motor control, how fast the motor should run. So this can also be controlled by the voltage or the duty cycle which we give. And yeah, coming light, okay, I want to specify that also. Whichever light you're using should be a PWM compatible. Only then you can do dim a light. Same goes with the motor. The sensor or the other things which you are going to attach to the arm should be compatible. Only then it works. Okay, so since now I've said about how exactly all this controllers works, and I've said we can just have a C file. And very first I said you just have to access this registers and write. Let's say I wrote let's say I took that register, I read the data sheet, I just wrote some value into this pointer value, and I want to flash it. How do I build it? Tejas, you may ask. Simple. There is something called ARM None EABI GCC. Okay, ARM None EABI GCC. You just have to download this. For this will have all these 3 things and many more things for all the platform. Let's say you are running a bare metal, that is normal C file. That time you just have to run this command and give your C file here and just flash using Eclipse or any other medium. Okay, same goes with this ARM and GCC. If you want to put a Linux in embedded, let's say in ARM core, I want to put a Linux, then you will use this. Fine, right? Okay, let's say I want to use this as a ARM None GCC. That is our bare metal. That is whatever I'm telling. Just write one small C file and just put a pointer and just write. That is called bare metal. Okay, you just define your own things and write. Let's say you want to put a whole Linux only in it. Just use this and it will build a whole Linux with this file. Okay, for this main compatible. And the same goes with this. Why I've done a custom link list linker script is whenever you have where exactly this ELF should be flashed inside your flash memory, that time you will use a linker script. Okay, same goes with Linux. And let's say you have different sections. Let's say we have different sections. Whenever you build an ELF, whenever you build one ELF, you'll have bss.data.code and heap and stack. All these memories will be defined, and this will be in LD file. I'm just running it fast because we are already running late, so I don't want to delay this much further. So I'm just trying to run a quick glance. You just note these things, and you can just even Google it, ChatGPT, anything. Take a small board and just try all these things. It will still work. Make sure that you read the data sheet before writing the C file in which register to access. I've just given the register values as example to just give a stat. Okay. Then after seeing that, if you want to see this ELF, how many memory is located, you can just use this for your extra information. Okay. Finally, advanced summary. So whatever I was trying to tell in all this discussion was that the peripherals can be used to interact with the data. Fine, right? And all the different type of peripherals I have covered is this. So we can have all this peripheral to interact. I would like to show again this picture. So what I was talking, this is the ARM. This is the ARM. And this I2C and SPI and all the peripheral which I showed also will be inside the ARM. Only the pins will be out. So we connect those pins to the sensor or something and do whatever we say. And how exactly the protocol works, I showed you here in every single protocol. So what is the significance and why do we have every single protocol in here? We already have the existing protocols. Okay, this if you have any questions, please be open to ask me. I'll be happy to. I really appreciate it. And if you want to reach out to me, and this is my number and this is my email address, you can reach out to me. Hello.
Any questions from audience? Tejas?
Yes, sir.
You finished completed, huh?
Yes, sir. I have done. I have completed it, sir.
I think there are no questions, Tejas. I think thank you very much for your valuable time. In a short
Yes, sir. It is my honor. It is my really honor to be here, sir. Whenever you call, you could have just even dropped a message. I would have taken it to my head like the way it was always in the college time. You were always our guru, and not only just given our knowledge, whatever I said, whatever I've learned from this technical knowledge, you have given us the life leading knowledges which have helped us more than technical knowledge and be a good person in life. I would always remember you, sir.
Thank you, Tejas.
It is my really big honor, sir.
I'm very proud to have you, as my student. And within a short period, I think you responded well and you could be able to just join us. On behalf of all our officials and all the faculty members, I thank you from the bottom of the heart for your wonderful session. I wish you all the best. Have a nice day. Thank you very much.
Yeah, means a lot. Thank you so much, sir.
Yeah. With this, I think we have come to the end of AROHAN series 23. I thank all the participants who have joined this session and made it a successful one. So we'll join for the next series on 1st of April. Thank you very much. Have a great day.